Hello everyone, welcome to my channel. And I think we have two circuits here. What are the two circuits here? We have this. This is a transistor amplifier using D882. Fixed bias configuration, common emitter. This is an amplifier I have, and this is my previous project. And we also have this. This is also an amplifier. This is a transistor amplifier using D882 power NPN transistor amplifier. The configuration of this second circuit is voltage divider bias configuration, common emitter, and we get a two amplifier here. So since you are dealing with sounds, we're going to amplify the sound using these two amplifier. This one I'm using D882 power amplifier transistor NPN, and this is a fixed bias configuration. And let us see the quality of sound we have. The circuit is on, and we're going to use an audio source. Let us use this. Oh, what is this? This is an iPhone 1, and I have phase out obsolete, and the screen, there's a black dot here. We're not going to use this iPhone, not this one. We're going to use this iPhone 4S as an audio source. Okay, we have here, and then we're going to use a 3.5mm jack from my old headphone, female header here. So let us now patch our audio source to the amplifier. Okay, let us now patch this. Now we have this, and then we're going to use a speaker. What speaker we're going to use here? The small one or the big one? Let us use this. What is this? This is concert. 80 watts. Impedance 4 to 8 ohms. Concert. Made in China. Sound of Denmark. Okay. That is the quality of sound. by this transistor D882 fixed bias circuit. This is a tweeter type speaker. That's why it has a high range frequency. That is the quality of sound of the first amplifier. So let us now see the second one. Did you hear the sound quality? It seems it's a little bit clearer than the previous one. So, these are my two amplifier circuits using the same, almost the same components I use. What seems to be the drawback of the circuit? Since this is my previous project, it seems that the drawback is a sound is low level. But the sound quality is a little bit nice, but very low. I need a high sound. And aside from that, it seems that the two amplifier I have has no volume control. I cannot control the volume. It is fixed. So, because of that, I'm going to show to you my new design, my new module with high level sound, and also the quality. And now we get this module. This is my new module. This is a Mosfet amplifier using IRF 540N. And we have this potentiometer or a trim pot for volume control. I have the input capacitor, the output capacitor, and a very big heatsink from my old computer motherboard. And we have here the Mosfet transistor. I use thermal paste. And then I have a header from my old PC board. This is a header also, the same. I have the header here at the front, and then I have the power LED here, and some resistor behind the volume control. So this is now, what is that? The paste. This is now my module, a Mosfet amplifier. We can see what is the quality of sound, the clarity of sound, and let us now see the circuit, how the circuit works. Let us now patch the supply as usual. I'm using a 12 volts power supply. Power LED turns on. The circuit is on. Now we're going to patch the speaker. Welcome to my channel, and we have 3 circuits here. We have this, that is a relay flip-flop, the alternating blinking of the LED. Okay, decreasing the volume. And these are my previous. We have also this. This is a transistor flip-flop. That is the quality of the Mosfet amplifier. We have now the volume control and a very high level sound, and the quality of sound is much better than the 2 amplifier. Again, adjust the volume. Program I use the blinking of the LED. So we have the DLC control or microcontroller control. We have transistor control and then relay control. What is the drawback of my design? Well, the drawback. Again. To my channel, and we have 3 circuits here. We have this, that is a relay flip-flop, LED, and these are my previous project. We have this is a transistor flip-flop using transistor. And the heatsink, it's very hot. the heatsink is very hot. Okay, that's the sound quality and the loudness of our new amplifier. Much better than the previous one.
Control or microcontroller control, the transistor control. What is the drawback of my design? Well,
Okay, let us now see the circuit diagram of this circuit. If you are interested in how to know the design of the Mosfet amplifier, we're now going to see the circuit diagram of this circuit. So this is now the circuit diagram of our new module. We have the Mosfet IRF 540N drain, gate, source. I'm using this because this is N-channel Mosfet transistor, commonly used type of Mosfet as an amplifier, and it is so easy to use. And we have a voltage range of 5 volts and 12 volts, so it works on two types of voltage supply. VDD, that is the voltage supply, and in here I got this, a power LED, that is the green one, in series with the resistor. And to the drain I connected this, a capacitor C2 for 70 microfarad, 50 volts. Why did I use the 50 volts for 70 microfarad? I choose this value because in order to get a frequency range, because of to listen to the voice and to the music at the same time, that is the frequency I need. So I use this capacitor with a speaker positive negative to the ground. As you have seen here, the speaker is now connected to the drain, and the positive is to the drain capacitor. Positive, negative, negative, positive. This is the speaker. And in here at the drain also I got this RGS. That is the resistor of the gate to source. Gate to source. Resistor of the gate. And we have now here the gate. Why did I put this 10 kilo ohms as a resistor to the gate? 10 kilo ohms is the universal value or a safe value always used in practical electronics again. And in here we get this input capacitor C1 for 70 microfarad, 16 volts. As you have seen here, that is the small capacitor. Also here I have the potentiometer or the volume control. That is now our volume control. The connection of volume control is this. Since it should be at the middle, the arrow pointing into the middle, the middle part of this string pot, the middle part of this should be connected to the input of the amplifier. And the other end, the left side, is connected to the ground. And the positive side, the other side, the right side, is connected to the audio source. Our voltage input here, by this alternating sign, AC source or a audio source, is this, a cell phone. That's our cell phone. So what do you think is the circuit configuration I use in this project? Is it common source, common drain, or common gate? Let us see. Here is the one circuit configuration. Only one drain resistor. I think this is not my circuit configuration. How about this type, voltage divider? This is not, because I'm only using one resistor to the gate. How about this one? This is a drain feedback circuit configuration. I think you might see here, you see here that this is my circuit configuration. A drain feedback. See? This is RG. Is now connected to the gate with a capacitor. I don't have this resistor because I'm not using this as a first stage. I'm not using this resistor because I'm not putting this circuit into this next stage. So I'm just using the RG. This is resistor is used if you're going to put the circuit into the next stage or the second stage. So this one is my circuit configuration. Drain, gate, source. I have the same capacitor and the load. What is my load? The speaker connected to the ground. So without this, only these components, we got now this circuit. See? With additional of volume control and power LED. We need this power LED to know that the circuit is on. So this is the transfer characteristic curves of the Mosfet. The x-axis, the y-axis, and the x-axis. We got in cutoff, the BDS, drain to source, is 0. As you have seen, as you increase the BGS, the gate to source of the Mosfet, you will reach into the point of saturation. This ID. Current flows into the drain. Different values of BGS. This is the operating point, the Q point of the Mosfet. And this part is the cutoff. And this part is saturation. And once you reach the saturation, if you're still increasing the voltage at the gate to source or the drain current, still you will got this region. You are now in this region, triode region. The switch is, the Mosfet is just like a resistor or just like a switch, saturated. So in this region, Q point of the Mosfet, that is the transfer curve of the Mosfet. So let us now see again our Mosfet amplifier. What is this IRF 540N? How to operate this component? It seems it is different from the BJT I'm always using. This type of component is a voltage dependent or voltage driven device or component. Unlike the transistor, that is a current control. This one is voltage control. So if we're going to trace the current flow, the green one, see the green one? That is the flow of direct current or DC. 12 volts to the drain, to the source, and to the ground. 12 volts to the resistor, to the gate. What happened here? Is the current still flowing to the gate, to the source? The current will flow into the gate and charging the built-in capacitor of this device. There is a built-in capacitor up to here. Once you apply a 12 volts, what happens is the characteristic of the Mosfet, it opens the gate. Once you apply a voltage of 12 volts, if you're going to use 12 volts, that is your voltage supply, the Mosfet will turn on, opening the gate, making the current to flow from drain to source. That is the case of DC biasing or the DC analysis. When you're speaking of DC analysis, that is the flow of direct current in the circuit. It will not flow here into the output, the DC, because actually it flows into the capacitor. But once it is fully charged, it will block the DC. And just like an open circuit here, open line. Also the same here in the input. Once the DC is flows here, the capacitor will now charge, and once fully charged, it will completely blocking the DC. So it will not affect this input source and also the output source when we are dealing with DC. How about the AC? We have two components of signal here or current flow. The AC signal from the audio source or from the cell phone flows by using this red line here into the gate, to the source, to the ground, to the resistor, up to the 12 volts, making this 12 volts. When AC is coming here, it seems like the 12 volts is grounded. The AC sees the 12 volt supply as ground, so it is ground. Also flows here to the drain, to the source again, and to the capacitor. Also flows here. You can see that in our demonstration demo, it fluctuates the LED. Also flows into capacitor, and when you are using this type of capacitor, it selects what type of frequency you are going to you need. Is it for the voice, for the music, high frequency or low frequency? Just pick the value for the speaker, and also here pick the value. So in here, why is it that the gate is open once you apply 12 volts? There is a certain parameters used in this type of amplifier, this IRF 540N. We have here voltage to drain to source, BDS. What is that BDSS in the datasheet? 100 volts. That is the maximum voltage you can apply to the output. Means this voltage 20 to 100 volts. Very big. And what is this BGS? Positive, negative 20 volts. Voltage at the gate to source. BGS is the maximum voltage you can apply to the gate to the source. Since this voltage supply, the maximum is positive 20 and negative 20. Why positive 20, negative 20? Because this is, did you see this line? This is an analog signal, negative, positive. It refers to this voltage source. This one, gate to source, positive, negative, 20 volts, BGS. Also referring to this for DC biasing. Should be 20 volts. If you apply more than 20 volts, the Mosfet will blow away. It will burn. And the drain current is 33 ampere according to the datasheet. So the 33 ampere is used. Also, we have this parameter B. What is this? BGS is equal to voltage threshold is equal to 2 until or up to 4 volts. What is that? Voltage threshold. Well, BGS is the maximum voltage you can apply to the gate, while BTS, or I mean BTH, voltage threshold, is the minimum voltage you can apply to the gate to turn on the Mosfet. And the maximum allowed voltage you can apply is 20 volts. And if we're going to use positive, negative, it means referring to the another signal source, AC signal, plus or minus 20 volts. And how about this? RDS on, less than or equal to 0.44 ohms. RDS refers to the internal resistance of the Mosfet. Other than that, nothing else. It's just the built-in resistance of the Mosfet once the current flows into the drain to the source. It is the on resistance. Very small. So just apply 100 volts here. And or 100 volts or less than 100 volts, the Mosfet will turn on because the built-in resistance is 0.44 ohms. So in here, I compute the values RD1, the power on LED, the resistor, using KBL, BCC, voltage drop, and the voltage drop equals 0. I got 10 volts using Ohm's law. 10 volts. And the voltage to turn on the LED, 2 volts. Here, current to turn on LED, 0.02 ampere. I got 500 ohms, but I use 1 kilo ohms because I'm using 12 volts. And 1 kilo ohm is the safe value. If you're going to use 500 ohms, the resistor is getting very hot. Standard values Use RB is equal to 10 kilo ohms. Standard values of pull-up resistor to gate to turn on Mosfet. See, standard values. This is arbitrary values. You can use 10 kilo ohms, 20 kilo ohms, or just 30 kilo ohms should be. And then what's the next one? I think we already know how the current flow here. So there's a sound travels to the capacitor, negative to positive. Still it can flow, even the polarity of capacitor. Reverse is still AC flows here. AC or the sound from the cell phone by adjusting the volume control here, then travels to the gate to amplifying the sound here, and the output is taken into the speaker. I need this capacitor for an AC. During the AC analysis, I need this to control the frequency of the capacitor, of the speaker. To control the frequency, I need to listen to the voice and music at the same time. Can you connect a speaker here in series? You can also connect, but I didn't use that because I need a capacitor here to make the quality of sound much better. So we have now this is my schematic using the header. So this is now the speaker, the cell phone, and then the trim pot or the potentiometer, my layout, power LED, and then the jumper settings for if I'm going to use 5 volts or 12 volts, it should still okay. The power supply, and aside from the volume control features and high quality sound, I got this. This is a test point. See that? The other two amplifiers have no test point. What is the test point? You're just connecting the cell phone to the speaker without amplifier. If I'm going to connect the speaker to the cell phone without using the Mosfet amplifier, it will sound like this. So let us now connect our test point. We have this. The cell phone one is connected here. Where is that? This is a test point without using a Mosfet amplifier. That is a new features of my design. Let us first connect the speaker here, and then the audio source. Okay, it's so hard. Where is the audio source? Oh, it's not that one. Speaker. Oh, it's okay. Speaker and the audio source or the cell phone. Since it's so hard, very hard, let us now test again. Using my favorite circle. Oh, wrong.
Here we have this.
Did you see that?
A really deep flow.
The quality is good because this is from the cell phone. Mm-hmm. I'm not a cheater.
My previous project. We have also this.
But the quality sound is good because I'm using the cell phone.
Transistor to provide to produce an alternating LED cluster.
How about using again
The other
the
one,
amplifier? And we have the volume control.
microcontroller control, the transistor control, and then relay control. What is the of well, the draw.
Play again. Increasing the volume.
Welcome to my channel. And we have three circuits here. We have this, that is a really deep flow. The alternating blinking of the LED with the use of a relay. And this is my previous project. We have also this. This is a transistor using transistor to provide pressure. Then the other one, that one, is being controlled by our.
That is now our new amplifier. We achieve our mission to have a volume control and a very loud sound. And the quality is okay. And you can use this in your living room or into your bedroom, or you can also make this as your new project using this design. See it again, hear it again, okay? See how the speaker, it's very loud.
Welcome to my channel. And we have three
Okay, thank you for watching my video. Bye. Bye.